This is the last unit in AP Calculus. This is area between two curves. And this is not a difficult concept, but it's time consuming to go through all the mechanics behind it. So I have it all drawn out and I'll explain it as we go along. When you're trying to find the area of a region between two curves, you're going to have to take the upper curve and it would give you the area below it. But then you want to take the lower curve, get the area below it, and subtract the two, and that's going to get the area between the two curves. So when we're looking at two functions of x, you're going to take the top curve and you're going to subtract the bottom curve. So this x squared plus 2 is the green parabola. Y equals negative x is my line. Parabola is on top, my line's on the bottom. So I'm taking my parabola, I'm subtracting my line. And the parentheses are very important. But I have to have a dx, so I'm going to put brackets around this to show that everything here gets the derivative with respect to x. And then I have to take my integrals. The left for this point I go is 0. The right for this point I go is 1. I solve this out where I go ahead and combine like terms. I then integrate that, and I'm careful at each step. So when I integrate this, I get x cubed over 3 plus x squared over 2 plus 2x, and I'm showing that I'm evaluating it from the lower limit of 0 to my upper limit of 1. I'm showing that I plug these numbers in, and I'm putting parentheses very carefully. I got a common denominator, and I got an answer of 17 over 6, and then I check it with the calculator. You don't have to combine like terms here if you want to. If it makes it more sense to you, if it makes it easier for you, just go ahead and take these two separate functions. So this x squared plus 2 dx from 0 to 1, and I subtract the negative x dx from 0 to 1. But make sure that you write everything correctly. You have to have your upper limit and your lower limit correctly. I have parentheses, I have a dx in both cases. Okay, my next problem, I have got a quadratic and I have a line. So once I graph them on here, here's my quadratic, that's my upper function, so 2 minus x squared. Negative x is my lower function, so this shaded area in red is what I want to find the area of. Find the points of intersection. Algebraically, I set the two equations equal to each other, factor, and solve. So my lower limit will be negative 2. My upper limit will be 1. So I'm showing that on here from negative 2 to 1. I combined like terms and rewrote it in descending order. You do not have to. So then I integrate negative x cubed over 3 minus x squared over 2 plus 2x. I'm showing that I'm evaluating it from negative 2 to 1. I plug the numbers in, showing each value as I go. I get a common denominator. I get my fraction and I reduce my fraction. I check it with a calculator. Now be aware, if you're doing this on a free response question, you can stop here because then if you make a mistake from here on out, you get points deducted. So this is appropriate answer for on a free response question. On a multiple choice question, you have to get this answer. They don't care about all the other stuff in between, but if you don't do all this correctly, you're not going to get this correctly. And on an AP test, this is probably a question without a calculator. My next question is finding the area between two intersecting graphs. I have a sine wave, which is this one here. And I have the cosine function, which is this one here. And there's different areas. I could have calculated this area here, this area here, there's an area here, and it keeps going. It doesn't matter which one I do. They're all going to be the same area. I've chosen this area from this point to this point, and I know that sine and cosine intersect at multiples of pi over 4. I wrote down all, but it's not all. In this scale, I went to 2 pi out here, so this is pi here. This is pi over 2, so here's pi over 4. This is 5 pi over 4. So my integral went, lower limit is pi over 4, my upper limit is 5 pi over 4. My upper function is sine x, my lower function is cosine x. And don't forget the dx. Integrate them carefully. Always in your mind, check by taking the derivative. So I get a negative cosine x minus a sine x. I'm evaluating it at pi over 4 and 5 pi over 4. I'm going to show where I plugged these values in on a free response question. You would need to show everything that you've plugged in. And I'm actually missing bracket there. Once you plug everything, carefully simplify it. And I get down to the square root of 2 plus the square root of 2, which will be 2 square roots of 2. Once again, if you are doing a free response question, you are welcome to stop. Actually, in this case, I think you could even stop right there, and you would be fine. This next one is more complicated. And the reason it's more complicated is I have a cubic function, which is the green one. I have this quadratic function, which is this blue one. And graphing these ones can get a little bit more complicated. You could do this on a calculator more than likely. To find the points of intersection, I once again set them equal to each other, but it's not always so simple as this. This actually came out to be a very simple problem, and I was able to find my points of intersection, but sometimes it's not that quick and easy. You need a calculator to do it, or a little bit more advanced knowledge in algebra. So when I set this up, I've got the first part from 0, or from negative 2 to 0. The cubic is on top. So I have to take the cubic minus the quadratic. But that's only from negative 2 to 0. The second part of this, the quadratic's on top, and the cubic is underneath. And that went from 0 to 2. So I had to take my integral from 0 to 2, take my quadratic minus my cubic. I cleaned it up a little bit. Like I said, you do not have to. It's whatever you find you're more comfortable with. So using algebra, cleaning it up. This is my left part right here. This is my right part from 0 to 2. I integrated it. And I evaluated it, the left part from negative 2 to 0. These are my numbers. My right part from 0 to 2. These are my numbers. I simplified and got 24. My last example gets more complicated. It doesn't always make sense to take your function as a function of x. So now what we're doing is we're looking at a function of y. So before we did dx. So if I were to go back to here, the very first problem, and I think of this dx, if you were doing Riemann sums, remember we were doing rectangles, infinitely many rectangles in this case, that went up and down. So each of these rectangles, you add them up. In this case, we're going to take these rectangles side to side. So now we're actually looking at this area between these two functions from here to here. In this case, we're not going to solve for y because the first function, if I were to solve this for y, I get y is equal to plus or minus the square root of 3 minus x. And then I do have to be careful. It is possible, but it is more complicated with the algebra. So then I'm going to find the points of intersection. And we did a little bit of graphing with parabolas in math analysis, but it's been a long time. I do think most of the time you're going to be given the graph, but if not, you can pick points and plot it. So now what I have to find is the points of intersection, but I don't care about the x values. I care about the y values. So notice I'm using y. I'm going to have to take the function on the right and subtract the function on the left. So the function on my right is my parabola, 3 minus y squared. My function on the right is the line, this y plus 1. I'm going to subtract them. But I have to make sure I'm going from -2 to 1. I don't care about my x values. My lower limit's -2, my upper limit is 1. I once again combined my like terms, but you don't have to. We could have done -2 to 1 of 3 minus y squared dy minus the integral from -2 to 1 of y plus 1 dy, and get the same answer. Once I simplified the algebra, I integrated, remembering to write my lower limit and my upper limit. I evaluated with 1 in the equation and then a -2 in the equation. I got a common denominator straight across and simplified it down to 9/2. I will do more explaining of this during the live lessons, but this should get you started.